Now let's look at a simple example. Let f of x be this integral that's going from 2 to x. When you see an integral that looks like this, constant at the bottom, x at the top, this is a big hint that you might need to use FTC part 1. Okay, so when you see something looks like this, this should give you some idea like, oh, FTC part 1 might be helpful for me, but we'll keep reading. Okay, so we have this integral, it's the square root of t squared plus 5 dt, and they ask you to evaluate f of 2. Okay, so now part A is asking you to evaluate f of 2, so you're not differentiate the whole thing, right? Because of that, we don't need to use FTC. Okay, so for part A, at least, we do not need to use FTC. So let's give it a try. So A, f of 2 is just gonna replace this x with 2, right? So let's give it a try. That's just gonna be from 2 to 2, square root of t squared plus 5 dt. Okay, recall that if you have a definite integral and the top and bottom, the upper bound and lower bounds are the same, look, they are the same, then the whole thing equals to 0. Right, you guys remember that? Why is this true? Why is this true? Because remember, for definite integral, what does it mean? Definite integral means the area or signed area under the curve, right? So let's say if my function looks like this, let's call this g of x. Then let's call this a, for example, and let's call this b. Then the definite integral ab gx dx is what? Is the area under the curve, right? It's gonna be here. Right, the area of this region, that's what it means. But if you top and bottom are the same, so you're looking for the area of here, but this, well, it doesn't have any area, the area is 0, right? So it should make sense to, whenever you have top and bottom, they're both the same constant, then you have 0. So part A, the answer is just 0. Now let's look at part B. Part B asks you to find f prime of 2. Okay? Recall that in order to find f prime of 2, we need to find f prime of x first, and then we sub in x equals to 2. So now, we first need to find f prime of x. And that's gonna be the derivative of this integral. And it's with respect to x. So we would have something like this. Now, well, looks like we need to use fundamental theorem of calculus part 1, but before we do that, let's check if everything matches. First of all, this integral is not about x, right? It's another variable. Second, you have constant here. 2 is a constant. You have a function of x which matches here, right? You can see you're differentiating with respect to x, and here is a function of x. Everything is good, so we can use fundamental theorem of calculus. And as I mentioned before, if we want to use it, we just sub this at wherever your t is. So just change t to x, and we're good. So this is just gonna be square root of x squared plus 5. That's my f prime of x. And now to find f prime of 2, we just need to sub in 2. So f prime of 2 is gonna be square root of 2 squared plus 5. That's gonna be square root of 4 plus 5, which is 9. And that's gonna give me 3. Okay? 3, not plus or minus 3, because the square root function is non-negative. Okay? It should not be plus or minus 3 because it's a common mistake. part C, now I need to find the second derivative of f. Well, I already know the first derivative of f, so to find the second derivative should be simple. We just need to differentiate this part, so let's do that. C f prime prime of x will be the derivative of this, so that's gonna be general, so we can write it as a power form first. This is basically to the power of 1 over 2. So to differentiate that, that's going to be 1 over 2 times x squared plus 5 to the power of negative 1 over 2. And then don't forget chain rule, so multiply by 2x because of chain rule. Okay? And those 2 and 2 can cancel out. I can rewrite it, of course. So let's rewrite it and write it as a square root back. So that's gonna be x over square root of x squared plus 5. And to find the f prime prime of 2, again, we just need to sub in x equals to 2. So f prime prime of 2 is just gonna be 2 over square root of 2 squared plus 5, which we already know what it is. Remember, that's just 3, so that's gonna be 2 over 3.